In this video, we will begin multiplying fractions, and we begin with 3/4 times 2/7. When you multiply fractions, basically you multiply the numerators across. 3 times 2 is equal to 6, and 4 times 7 is equal to 28. And then you look at your product here and ask, can it be reduced? Notice how each of these is even, and I can divide each by 2. So divide the numerator and the denominator each by 2, and that will get us to 3/14. Now there is another way to do this problem. Quite often people like to cancel first and then do their multiplication. If that's the case, you can cancel straight up and down or on a diagonal. For example, on this diagonal, 4 and 2 are both divisible by 2. When I divide each by 2, I get a 1 up in the top right and a 2 down in the bottom left. And then we can multiply across and get 3 times 1 is 3, and across the denominator, 2 times 7 is equal to 14. And we get the same number. One way we multiply and then reduce, the other one we reduce and then multiply. But it's important that you only cancel on a diagonal or straight up and down, and that you don't cancel numbers that are across from each other. Okay, let's multiply another set of fractions together. Now, before I multiply, I'd rather do my reducing first in order to multiply smaller numbers. Now notice how 4 goes into 12. 4 times 3 is 12. But also notice 3 goes into 12. So we can cancel either on the diagonal or straight up and down within the fraction. I'm going to do that. Within this fraction, both 3 and 12 are divisible by 3, so dividing 3 by 3 I get 1, and 12 by 3 I get 4. And then I'm going to cancel on the diagonals. I have 2 different 4s, so I will cancel them with each other, dividing each by 4 to get 1 in both of those places. Now what I like to do sometimes, just so that I can check my work, is have some forward slants and some backward slants so I can tell which numbers got canceled with which. Some people like to just scribble everything out. Now the advantage there is you only see the numbers that remain. The disadvantage with that is you can't check your work very easily, so I don't know that I recommend the scribble out method. But looking at what's left, we have 1 times 1 in the numerator, so that's 1, and 9 times 1 is 9 in the denominator. Let's say you're asked to multiply a whole number by a fraction. Let's say we have 15 times 2/3. Anytime you are multiplying with fractions and you have a whole number, you want to write that whole number over 1. That's the only trick before you begin multiplying. Now, I'm going to reduce first. I notice 3 goes into 15 5 times. So canceling those two, dividing each by 3, I get 5 in the top left and 1 in the bottom right. When I do my multiplication, I now have 5 times 2, which is 10 in the numerator, 1 times 1, which is 1 in the denominator. And to simplify this, since it's over 1, we'd rather write this as the whole number 10. And that would be considered to be the simplified product. Remember, product is the answer to a multiplication problem. Now let's look at a fraction raised to a power. Remember how when you're raising something to a power, that exponent is telling you how many times the base is multiplied by itself. So in this case, we can either write this as 2/3 times 2/3 times 2/3 times 2/3 if we want, and multiply across the numerators. 2 times 2 times 2 times 2 is 16. Likewise, in the denominator, we'll have a product of 81, and get our answer that way. Or some people take this 2/3 to the 4th power and they say, you know what, let's write that as 2 to the 4th over 3 to the 4th. And that way we can go to our 16 and 81 in that manner if we wish. If we have a fraction which is a power of 10 being raised to a power, such as the 3rd power, notice how you're going to have a numerator of 1 times 1 times 1. That will give us 1. And down below in the denominator, 10 times 10 times 10 is 1,000. Notice with that 1,000, there are 3 zeros. The exponent here is 3. That exponent will match the number of zeros in the denominator. So if I have 1/10 being raised to the 5th power, that'll be 1 over 100,000, because 100,000 contains 5 zeros. Now let's multiply two mixed numbers together. Anytime you're doing this, the numbers can get a little bit messy on you. You do not really want to separate the whole numbers and multiply them and then the fractions and multiply them, because you might get the wrong answer. In fact, you probably will get the wrong answer. So what you'd like to do is convert each of these first into improper fractions. Here we'll take this 3 in the denominator, multiply by 3 on the side to get 9, and add that 1 on to get 10 placed over the 3. And we would then multiply that by 4 times 2 is 8, plus 1, that makes 9 over 4. Then we will multiply them together in this form and then simplify. I notice on one diagonal, 3 goes into 9, each of them being divisible by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3. Likewise, on the other diagonal, I can cancel and see, they're both divisible by 2. 10 divided by 2 is 5, and 4 divided by 2 is 2. Multiplying across now, I'm going to have 5 times 3 is 15, and 1 times 2 is 2. Now, technically, that is your answer. Now, since we began with mixed numbers, we probably want to write our answer as a mixed number. So we would do division. 2 goes into 15 7 times, with 1 left over, so that would be 1 left over the 2. Now, it's very important that you realize when you're canceling like this, you are only canceling across a times sign. If that is a plus sign, minus sign, division sign, equal sign, you cannot cancel. You can only cancel straight up and down or on the diagonal when there is a multiplication sign. Well, you can always cancel straight up and down within a particular fraction. Now, let's find the area of this rectangle that has a width of 3/5 meters and a length of 1 2/3 meters. Now, when you are finding the area of a rectangle, again, area is equal to length times width, or base times height. So we're going to take that length of 1 2/3 meters and multiply it by 3/5 meters. Well, some people like to just leave the meters off and put the units back on at the end, which is fine. I need to convert this mixed number into an improper fraction. 3 times 1 is 3, plus 2 is 5. So that gives us 5/3 meters times 3/5 meters. Okay, when I go to multiply here, notice how I get cancellation, because 5's will cancel and 3's will cancel. Be careful, our answer is not 0. When I canceled those 5's, I divided each by 5 and got 1's. And 3's got canceled and I got 1's. So I really have a product here of 1. I've got meter times meter, which would be meter squared. So 1 square meter would be the area of that rectangle. Now let's find the area of this triangle. The formula for the area of a triangle is 1/2 base times height. And you've got to be very careful with triangles that you have the true height here. Do not get it confused with the slant height here. Okay, you always want this height straight up from the base. This little square that's put in the center here says that that dotted line going up through the center of the triangle is perpendicular or at a right angle to the base. And that means it's standing up straight. And so 3 1/2 centimeters is the true height of the triangle. Now, we're going to multiply together. We're going to have area equals 1/2 times the base of 4 times the height of 3 1/2 centimeters in each of these cases. And I'm going to take this 3 1/2 and rewrite it as an improper fraction. I'm going to write this 4 also to be over 1. 2 times 3 here is 6, plus 1 is 7. So I will have 7/2 as that final fraction. Now, canceling 2 and 4, both can be divided by 2, so I get a 1 and a 2. Then I can cancel the 2's on the diagonal, getting 1's in both of those cases, and all that's left here is going to be 7. Now I've got centimeters times centimeters. Area is always measured in square units. And so the area of that triangle would be 7 square centimeters. Now let's take a look at a word problem here involving a fraction. A car holds 15 gallons of fuel. If the tank is 3/5 full, how many gallons are in the tank? Now, our brain tends to turn off here, and I know we're in the multiplication section, but if we weren't, how would you know that we're supposed to be multiplying these together? Well, I suggest the following. Try changing this into a fraction or a whole number that our brain can process a little bit better. For example, if that was half full, you'd say, oh, half of 15 gallons, that's 7.5 gallons. Oh, to get that I went 15 times 1/2. And now we go back to this problem and say, oh, well, it's 3/5 instead of 1/2, so let's multiply. And so that might be a technique. Change it to a fraction that you're comfortable with to determine that this is a multiplication problem. So we're going to have 15 getting multiplied by 3/5. Since we're multiplying by a whole number, I'm going to write that 15 over 1. And then I'm going to reduce these fractions, and we notice that on the diagonal, 15 and 5 will cancel. I can only cancel diagonally across the multiplication sign. Each of these are being divided by 5, so we're going to end up with a 3 in the top left corner. And 3 times 3 is equal to 9. And if this filled, or 3/5 full, how many gallons are in the tank? Answer, 9 gallons. It's always important to get the unit on our answer, especially in a word problem.